Hello, I'm Dr. Pods, and in this video I want to show you how to analyze an LR filter, so a filter with an inductor and a resistor. I'm starting from the results of the previous video, which did look into RC filters, and I will just see what difference does it make if instead of the capacitor we have an inductor at this place. Obviously we need to delete everything that is related to this capacitor here, and we remove the capacitor there. And now we can draw an inductor in this place. Just going to use a different color to highlight this. So we have an inductor, an RL or LR filter at this place, and we're looking at UL as the output voltage, the voltage over the inductor. The impedance of the inductor is actually slightly simpler. It is J omega L. So you can see again J the imaginary unit, omega the circular frequency, and L the inductance of the inductor. Otherwise, we can use very much the same equations. So we use the inductance, the impedance of the inductor. We're looking at the voltage over the inductor, impedance of the inductor. And now this is where the equation begins to change. So we get in the numerator, we get J omega L, and in the denominator, again, R plus J omega L. And in fact, this is our result because there's really no need to simplify this by much. We can rewrite it if we like, and it would look J omega L divided by R divided by 1 plus J omega L divided by R. And this is just so that the pole is more obvious in the denominator. So what kind of a filter do we have here? We can apply the same analysis as before. We can assume a very low frequency omega, and you can see that this very low frequency obviously means that the 1 dominates. We have a 0 in the 0 in the numerator, 1 in the denominator, and so the result would be 0. And at very high frequencies, the omega term dominates, so at high frequencies we have 1. And as discussed before, this means we have a high-pass filter now. So we're replacing the capacitor with an inductor. We turn the low-pass filter into a high-pass filter, which seems perfectly reasonable given that they have kind of the opposite behavior. Let's have a look at the second filter that we have here. There we are. So if we insert an inductor here, again create an LR filter and now take the voltage over the resistor as the output, very much the same happens. So we replace this term here with J omega L, and we find that again we can rewrite this slightly if we like by dividing through R. We get 1 over 1 plus J omega L divided by R. Again, we can look at how this behaves for very low or very high frequencies. So for very low frequencies, we can see the 1 dominates, so low frequencies pass through this filter. High frequencies, the omega in the denominator dominates, and we get 0. So the conclusion is that we have created a low-pass filter here. Again, that is perfectly obvious. It's the opposite of what the RC filter was here, and it's the opposite of the filter with the output over the inductor. So I hope this was useful. We've covered the 4 basic first-order filters now, and I will show you how to draw both diagrams in one of the next videos.